Welcome to Dark Sky Dive. Today, we explore the engineering marvel behind the modern space race, the legendary Falcon 9 rocket. Throughout the history of space exploration, humanity believed that every single rocket built could only be used for one single flight. After leaving the launch pad, these magnificent machines became burning metal, disappearing into the ocean depths or disintegrating in the upper atmosphere. This wasteful paradigm continued for decades until SpaceX emerged with a radical vision to change the economics of space travel forever. The Falcon 9 is not just a rocket. It is an industrial product designed explicitly for rapid reusability and mass production. It was born from a production line possessing a mindset closer to the automotive industry than to traditional aerospace manufacturing methods. And everything begins with something that looks surprisingly ordinary. Giant sheets of aluminum alloy waiting to be transformed into starships. The Falcon 9 is not constructed from heavy steel or exotic materials found in science fiction movies, but from aluminum-lithium. This specific material is significantly lighter than steel, yet it remains durable enough to withstand immense fuel pressure during the flight. It must also survive the violent vibrations and terrible acceleration forces that occur when the rocket blasts off from the Earth. Inside the factory, these massive aluminum sheets are cut by high-precision CNC machines to create the perfect shape for assembly. Once cut, they are fed into rollers that bend them into cylindrical shapes, forming the basic structure of the rocket body. They use friction stir welding, a technique that joins metal without melting it, creating a bond that is almost seamless. There is absolutely no room for error here. A single microscopic crack could cause the entire rocket stage to be scrapped. Individual body sections are joined together to form massive cylindrical segments, creating the main fuselage of the Falcon 9 rocket. These segments will eventually become either the massive first stage booster or the smaller upper stage that reaches orbit velocity. These metal tubes stand dozens of meters tall, yet their walls are incredibly thin relative to their massive overall size. The walls are so thin that they could easily buckle or deform if handled incorrectly during the manufacturing or transport process. During production, they are always kept vertical and supported by special frames to avoid any unnecessary force on the structure. The Falcon 9 is not designed to be rigid when empty. It only gains its full strength when pressurized with fuel. If the aluminum body is the skeleton, then the Merlin engine is undoubtedly the beating heart of the Falcon 9. Each Falcon 9 rocket utilizes 9 Merlin engines on the first stage and 1 specialized vacuum engine on the second stage. The Merlin engine was designed with a specific philosophy: fewer parts, simpler mechanics, and the ability to be mass-produced. Engine components undergo precise machining and rigorous testing to ensure they meet the strict standards required for spaceflight operations. Every valve and pump is tested for pressure and flow rate individually before being assembled into the final engine unit. Each engine must withstand temperatures reaching thousands of degrees and extreme pressure without melting or failing during the launch sequence. Crucially, they must also possess the capability to restart multiple times in the vacuum of space for landing maneuvers. Installing one engine is difficult, but coordinating 9 engines to work simultaneously is a much harder engineering challenge to solve. The Merlin engines are mounted into the Octaweb, a strong metal structure at the base of the first stage booster. This layout is designed to distribute the immense thrust forces evenly and make maintenance easier between different flight missions. All engines must burn fuel at the exact same rate and generate balanced thrust to keep the rocket flying straight. They must not vibrate out of sync. Just one engine performing incorrectly could destroy the entire vehicle in seconds. Once the rocket body and the engine cluster are complete, they are mated together to form a full booster stage. At this stage, the Falcon 9 finally begins to look like a real rocket, standing over 70 meters in height. It will weigh hundreds of tons when fueled, Systems for fuel delivery, avionics, and flight computers are now fully integrated. The flight computer acts as the brain, controlling steering and stability, processing thousands of data points every single second. Everything is designed with a modular philosophy, allowing parts to be removed, inspected, and reinstalled quickly for the next flight. Unlike traditional rockets of the past, the Falcon 9 was born with the unique purpose of returning to Earth safely. This requires specialized hardware, including landing legs that fold flush against the fuselage and deploy only moments before touchdown. It also features titanium grid fins near the top, which steer the rocket through the atmosphere during its hypersonic descent. These components are not optional accessories. They are integrated into the core design and manufacturing process from day one. The Falcon 9 does not simply fly upwards. It must survive the journey home to be flown again and again. Before it is ever allowed to launch a satellite, every stage must undergo a full-duration static fire test. The rocket is erected vertically and clamped down tightly to the ground, ensuring it does not move during ignition. It is then filled with fuel and liquid oxygen, simulating the exact conditions it will face on launch day. Then, the engines are activated for a few intense seconds, unleashing millions of pounds of thrust against the hold-down clamps. This is the moment where data cannot be faked. Any hidden manufacturing defects will be exposed by the raw power. If there is any anomaly in the data, the rocket returns to the factory for inspection. There are no exceptions. The secret to their success is not just a single technology, but a complete shift in the manufacturing mindset. SpaceX manufactures the vast majority of their components in-house, reducing dependence on external contractors and slow supply chains. They iterate on the design constantly. The Falcon 9 is not a static museum piece. It evolves with every flight. Each rocket leaving the factory represents thousands of hours of design work and lessons learned from previous failures and successes. It embodies a bold philosophy that space travel must become routine, reliable, and accessible for the future of humanity. The Falcon 9 has changed not only how we launch satellites, but how we think about building rockets efficiently. From silent sheets of aluminum alloy in a factory to a blinding pillar of fire tearing through the sky. This incredible journey begins not at the launch pad, but right there on the production line we have just witnessed. Every hand that touches the metal contributes to the mission, forging a bridge between our planet and the stars. As the booster separates and begins its return, we see the culmination of manufacturing precision and aerodynamic engineering in action. The engines reignite against the supersonic flow, a feat that was once considered impossible by many aerospace experts. Guided by algorithms and grid fins, the massive metal cylinder navigates through turbulence to find its designated landing spot. In the final moments, the landing legs deploy, ready to catch the falling building and bring it to a halt. A soft touchdown completes the cycle. What was once deemed science fiction is now a regular Tuesday occurrence. But the story does not end here. The rocket returns to the hangar to be inspected and prepared again. They check the engines, clean the sensors, and verify the structural integrity, proving that reusability is economically viable. SpaceX has built a fleet of veteran rockets, drastically lowering the cost of access to orbit for everyone. This production capability enables massive projects like Starlink, connecting the world through thousands of satellites launched by these machines. It also allows humans to fly safely to the International Space Station, restoring independent human spaceflight capabilities to America. The lessons learned from the Falcon 9 production line are now paving the way for the next giant leap, Starship. But let us not forget the human effort. Thousands of welders, coders, and engineers dedicate their lives to this vision. Precision is their religion. Innovation is their currency. And the sky is no longer their limit, but their playground. They are inspiring a new generation of dreamers who look up and see opportunity instead of just empty void. The modular manufacturing process even allowed them to strap 3 cores together to create the powerful Falcon Heavy rocket. Seeing 2 boosters land simultaneously remains one of the most iconic visual achievements of modern industrial engineering. It is a cycle of raw material becoming intelligent motion, a testament to what focused human engineering can achieve. Behind every smooth launch are years of hard work, sleepless nights, and the relentless pursuit of absolute perfection. As the rocket stands silent on the pad tonight, it is ready to write another chapter in history. This symbol represents more than a company. It represents a species refusing to be bound to a single planet. From the bottom engines to the payload fairing at the top, every inch is optimized for performance and cost. Inside the nose cone, precious cargo waits to be deployed, expanding our communication networks and scientific understanding. Even these fairing halves are now recovered and reused, saving millions of dollars with every single launch mission. Every part of the rocket is analyzed for potential reuse, driving the cost down further than anyone thought possible. This economic efficiency is the key that unlocks the door to Mars and permanent settlements on other worlds. The ultimate goal remains clear: making life multiplanetary. The Falcon 9 is the workhorse building that future foundation. It is built by people who refuse to accept the status quo, who believe that impossible is just a word. The beauty of the Falcon 9 lies in its function. It is a machine stripped of all vanity. As it breathes cold oxygen on the pad, it seems almost alive, waiting for the command to ignite. The countdown sequence is an automated symphony of checks and balances, ensuring every system is green for go. Ignition. The hold-down clamps release, and the rocket fights gravity with sheer brute force and fire. It clears the tower, accelerating faster and faster, pushing through the thick atmosphere towards the vacuum of space. For a moment, we defy the laws of nature, escaping the bonds of Earth to touch the infinite void. From up here, our planet looks fragile and beautiful. The rocket is the tool that gives us this perspective. The mission is accomplished. The payload is delivered. But for the booster, the journey is only half over. It falls back towards the ocean, a guided meteor controlled by mathematics and high-strength aluminum alloys. It rides the heat of re-entry, protecting itself with its own exhaust plume, a dance with physics. The grid fins work overtime, fighting the aerodynamic forces to keep the vehicle on target for the landing zone. Waiting in the Atlantic is a robotic ship, a tiny landing pad in the middle of a vast ocean. It pierces the clouds, slowing down rapidly as the single center engine performs the final suicide burn maneuver. Contact. The beast is tamed. It stands tall on the rolling waves, ready to sail back home. Back at port, it is washed and inspected. The cycle of production and operation is now a closed loop. A used rocket is no longer trash. It is a proven asset, more valuable than a brand new one. The data gathered from these returned boosters helps engineers refine the manufacturing process for the next batch. They use advanced techniques like 3D printing to create parts that are impossible to make with traditional casting. Simulation and reality merge. The factory learns from the flight, and the flight learns from the factory. This is the new era of the space age, an era defined by speed, reuse, and industrial scale. We do this because we must. Exploring the cosmos is the best insurance policy for the future of humanity. It takes the brightest minds to solve the hardest problems. And they are doing it right here, every day. The production line never stops. As one rocket launches, another is already taking shape in the welding bay. And so, another sheet of aluminum begins its transformation. Another journey from the ground to the stars begins. The Falcon 9 is a bridge built of metal and fire, connecting our present to our future. It sustains our presence in orbit, delivers our satellites, and keeps the dream of exploration alive and well. Night or day, rain or shine, the machine performs its duty with robotic precision and reliability. We have witnessed the entire life cycle of this industrial marvel, a process of magic, science, and nutrition. From the raw ingots of metal to the complex assembly of engines, every step is a calculated masterpiece. The people who build these machines are the unsung heroes of the 21st century space revolution. The Falcon 9 stands ready, a testament to human ingenuity and the relentless drive to explore the unknown. The stars are waiting for us, and thanks to this production line, they are closer than ever before. Aluminum, engines, assembly, testing, and flight. This is the anatomy of the world's most successful rocket. As we watch it fade into the sky, we know that this is just the beginning of the adventure. Space is hard, but with the right engineering and the right mindset, it is not impossible. Thank you for watching this journey into aerospace engineering. Subscribe to Dark Sky Dive for more deep dives into space technology.